Hello, welcome to another Gunforged deep dive video. In this video, I'm going to be working on part 2 of the skeleton snake boss. Part 1 is linked below if you'd like to watch that. So we're about halfway done with the boss. Got to fix the pathfinding and the snake follow behavior, and also add 1 or 2 more attacks to the snake as well. So we're going to be doing that in this video. And the first thing we'll do is let's take a look at what the snake currently looks like. All right, so here's the snake as it currently exists. It kind of moves around the level randomly and spawns these bone spikes. So you can see that the pathing is a little bit weird with it, and it doesn't flip correctly, and it can clip through terrain. So it's getting there, but it's not quite there. So we're going to be fixing all those things, and we'll hopefully be able to prevent it from making super sudden changes in direction as well, so that it doesn't double back on itself like it just did right there. So let's work on the follow algorithm first. Okay, so in the process method, so every frame, I'm calling this update body segments function. And this update body segments function basically is responsible for iterating over all of the body segments and updating their positions. So the way that this works is it's basically storing all of the prior positions of all of the segments, and then the segment that comes after that segment as the snake is moving will reference those prior positions to decide which direction and velocity and all that it should have. So this is producing errors that build up over time and prevent the body segments from following the exact path of the head. So what I'm going to try instead is use a curve 2D to create a more accurate follow based on where the snake is going. So the head is basically going to create the curve as it's moving, and then all of those body segments are going to follow that curve based on the offset that they are away from the head. And we can use that offset to sample baked points in the curve to set up the proper position. So that's what I'm going to try. I don't know if it's going to work, but let's see. So I'm looking at the curve 2D here, and it's got a couple of relevant functions in here. We're going to want to add points, and we're also going to want to sample baked here. So sample baked takes an offset, which is in a distance along the curve. And then what I'm going to do is basically use this offset to sample the position of each individual segment position. So I don't want to set a point necessarily every single frame. So I'm going to actually set a timer on the skeleton snake, and hopefully that's going to perform all right. I just don't want to clutter up the curve 2D with hundreds and hundreds of points. So let's go ahead and add a timer, path point interval timer dot timeout plus equals on path point interval timer timeout. Okay, so we'll scroll all the way down. I'm going to create that method, private void on path point interval timer timeout. And what I'm going to do is I've got a reference to the head segment here. So I'm going to say path curve dot add point head segment dot global position. Okay, so we're going to add a point every time. And then I'm also going to add a little bit of a check here, which is if path curve dot point count. I'm going to say, I'm just going to limit it to 200 for now. I'm going to remove a point, and that means I'm going to remove a point at the end, which is going to be, well, the first point. So I'm going to say path curve dot remove point 0. So we're going to cap it at 200 points. Okay, so now when we do this update body segments, we can use that curve. So I don't know how this is going to work initially when there aren't enough points to spread out through the snake. They might just end up all bunching up at the same point, but we're going to see. So I'm going to get rid of all this stuff. We're just going to rewrite this entire method here. So this update body segments, what we're going to do is we are going to go one by one, and I believe there's a constant value here, body segment distance. So this is the distance between each body segment. So this is what I can use to determine what the offset should be along the curve. And the other tricky thing about this is that the end of the curve, so the last point added to the curve, is actually where the head should currently be. So we actually need to start from the end and work our way backwards. Okay, so that's our curve length, and we're going to need to work backwards from that. For var I equals 0, I is less than body segments array.length I plus plus. Var offset from end equals body segment distance times I. And that should basically be it. Now, what I probably want to do is skip the head position. Since the head is the driver, I really probably shouldn't be resetting the head position based on the curve. So I'm actually going to start it at 1 to skip the head. So the head is basically the thing that is moving independently, and then the rest of the body segments are going to be the things that follow it along the curve. So let's see how badly I broke this, and then we'll move from there. Okay, I think that this is generally looking good. It's a little bit choppy though, and I wonder if that has to do with the curve length here. This video is sponsored by me. If you want to learn how to build a complete game in the Godot engine using either C# or GDScript, check out the links to my Udemy courses in the description below. So that jitteriness actually is probably related to the interval at which I'm placing the point. So I need to figure out a better way of getting those points situated, because I think what's happening is that the head point is not being updated in a way that makes it so that these body segments can be updated. And instead of doing this path point interval timeout right here, what I'm going to do is I'm going to, in update body segments, I'm going to add the point always. So we'll add the point there. But then what I want to do is I want to say if curve length greater than body segment distance times body segments array dot length times 2. So I'm basically going to say if the curve length is greater than twice the body length, roughly speaking. The reason I'm multiplying by 2 is I don't know the exact body length, so I'm just multiplying by 2 to give myself a little bit of extra space. If the curve length is greater than the body segment length, then what I'm going to do is I'm going to remove the first point. So I'm going to do path curve dot remove point at 0, like so. Okay, and then I'm going to have to reassign the curve length in that case again, because the curve is going to be changing. And then I should be able to sample all those points. So I can get rid of this path interval timer, because I think the reason why it was being choppy is because of that time interval. Not placing enough points on the curve fast enough. So hopefully this new way of doing it, it's going to be adding a point to the curve very often, but what should happen is that it should at least cap the length. All right, that appears to be working great. Now I could lerp that transform if I wanted to, but I don't think that's necessary. So with all that in place, now we got to do the next tricky thing, which is to properly flip the visuals of everything based on which direction the snake is going. So this head needs to be flipped vertically if it's facing to the left. I'm just going to do this the way that I know how to do it. I'm sure somebody in the comments is going to tell me a much easier way of checking. Basically, if you imagine a circle, a unit circle, I want to check if the rotation of the body segment is somewhere on the left half of the circle. But because of the way that Godot returns the rotation degrees, it's kind of nonsensical. So there's a trick here that I can do, which is I'm going to take the rotation degrees and I'm going to take a vector and rotate it. So I'm going to say var rotated vector, or I'm going to say maybe facing vector is equal to vector2.right.rotated degrees, rotation degrees like so. And I actually don't need this now. I can do global rotation and then I can just do rotated. Okay. And then since I have got the facing vector now, since right is an angle of 0 and I'm rotating it, I should have it facing the angle now of the sprite. And what I can do is I can take the dot product of vector2.left and this facing vector to figure out if it's facing left. Because if you take a dot product, so if I take left dot this facing vector and the dot product is greater than 0, then the vectors are within 90 degrees of each other. So they're roughly facing the same direction, right? So I can do if, or actually I don't need if. I'm going to say body segments array I dot flip v is equal to vector2 dot left dot dot facing vector is greater than 0. And so that's going to tell me that this facing vector is within 90 degrees of the left vector, which means it's basically what I'm going for, which means that the angle is on the left half of a unit circle, if you imagine that. So with all that done, let's see if this starts to work now. It's flipping very nicely, actually. So now I'm going to apply that same logic to the head here. So now the head segment and all the body segments are flipping properly in accordance with their direction. The body segments are all following each other, which is great. And so now what I want to do is I'm going to do a little bit of cleanup, and then I want to see if I can limit the amount of rotation that the snake can do at once based on its pathfinding, because it keeps doubling back on itself, which I don't think is very good. Okay, the snake movement issues were actually stumping me, so I had to take a break for a couple of hours, but I think I have a solution now to prevent the snake from getting stuck on walls and whatnot, and it really was as simple as moving that change, this max direction change that I was using, out of the pathfind component and putting it instead in the velocity component. So now the pathfind is not the thing being affected, but rather the velocity as it tries to move in a direction. So what I've done is I've essentially said, here's my max angle change degrees. And I might actually rename this max angle degrees change, because it's not necessarily per second. It just basically says, if the angle difference between the direction that I want to go in and my current velocity direction, if that's greater than this threshold here, then I'm just going to clamp it. So it's basically the same thing that I was doing before, and I clamp it here. And that actually produces a much smoother turn, and also that turn speed is going to be limited by things like the acceleration coefficient. So it's going to be naturally limited. I'm basically just saying you can't turn more than this amount in a single frame. And every incremental improvement that you make toward being able to completely turn in the desired direction is going to be based on the configured acceleration coefficient. So I think this is a much nicer way of doing it, and it looks much nicer. Now, he still gets pinched in those little corners there, but I actually think that's fine. I don't think it needs to be perfect. The main thing is that he is snaking around the level like he should be, and I think that's a good thing. So I think it's time to move on and add another attack to him. But first, I'm going to modify this bone spike attack because it's currently spawning outside of the arena. This was a problem that I mentioned I was going to address. And I'm going to look at this bone spike attack timer here. Min spikes, max spikes. I'm actually going to change this to 10 and 20. Min spike radius and max spike radius. These things are going to go away. And what I'm going to do instead is in this acquire target, I actually have a bunch of code here I can delete now. That's a good feeling right there. So in this acquire target position, I'm doing this. So what I'm going to do is I'm going to basically copy this, and I'm going to actually do this. I'm going to return this vector2. I'm going to rename this to get random navigation map position. Then I'm also going to pass in a bool uniform equals false. And then I can pass that in here. And I am going to want a uniform distribution when I'm doing the bone spikes, so I don't get a bunch of bone spikes just stacked up into a single place. So I'm just going to replace this acquire target position with get random navigation map position like so. But then when I'm spawning the bone spikes here, I'm going to get rid of this. And my bone spike global position now is going to be equal to get random navigation map position with the flag true set. So I upped the number of bone spikes and changed how they spawn. They're now global. So now they should spawn basically anywhere in the map. Okay, so it's actually the next day. I needed a little bit of time to think about what I wanted to do with the snake boss next, but I think I have it figured out. So what I want to do is I want to add some sinusoidal movement to the head to make it look more snake-like. And I want to add some variability to this. So there's going to be some times where the snake is not moving in a very snake-like way, and then other times when it's moving in a massively snake-like way. And I want to see what that feels like. And then I want to add some attack based on that sinusoidal movement. So I think this is going to be a little bit tricky to do, but I'm going to give it a shot. I'm going to see if I can maybe use some steering behaviors with what I've got currently to drive the sinusoidal movement, and we'll see what happens. So I'm actually going to not use this follow path functionality for the pathfind component anymore. All this is doing is this is accelerating the velocity component in the direction defined by the distance or the direction to the next path. So I'm actually going to do this. I'm going to say public vector2 get path direction. And in here, what I'll do is I'm going to return vector2.0 if the navigation is finished. So I'm going to return vector2.0, and I'm going to get rid of this decelerate. Otherwise, I'm going to return this. And I can actually simplify this even. Get next path position. So I can simplify this and just do global position dot direction to this. That's a nice built-in Godot method that will normalize it for me. So I can do all that stuff. And then what I can do in here is I can replace that call with this. Get path direction. If direction is equal to vector2.0, then we're going to do velocity component dot decelerate. Else do that. And I can get rid of this. So now I can get the path direction only. And that's what I'm going to do in the snake here. So in my state normal, I'm going to say var path direction is equal to pathfind component dot get direction. And instead of calling follow path here, what I would do instead is I would take the velocity component dot accelerate in direction, path direction. But now I can add some sinusoidal movement. So let's say private vector 2 head direction. And then let's do private float head angle degrees. Actually, we probably just need a head angle degrees. So what I'm going to do in the state normal is I'm going to say head angle degrees plus equals, we'll just do maybe 20 degrees per second for now. So let's multiply this by get process delta time. And then what I'm going to do is I'm going to say var head direction is equal to vector2.right.rotated head angle degrees. And this, I'm going to clamp it so that the X value is always positive. So I'm staying on the right hand of the unit circle if you're imagining it. So I should be able to do this. Head direction dot X is equal to mathf dot apps head direction dot X. So I'll take the absolute value of that. And now that I've got this head direction, I actually need to rotate it again by the direction that the snake is supposed to travel. So what I'm going to do here is I'm actually going to take this whole block here and I'm going to move it down here. When we get this path direction here, so now we've got a head direction. This represents basically how much off the path to deviate. So I'm going to take this path direction and I'm going to rotate it by the angle of the head direction here. So I'm going to say path direction is equal to head direction dot angle. Actually, this needs to be path direction dot rotated head direction dot angle. And so this head angle degrees is just going to keep increasing, but it's going to just keep rotating around a circle. What I can do if I want to is I can do head angle degrees equals math f dot wrap. And I want to wrap the value, which is head angle degrees plus this. And I want to wrap it between 0 and 360. So that just prevents the number from growing large. That's probably not really necessary in a practical sense, but we'll go ahead and use that. This needs to be dot rotated degrees. I could use radians for this if I wanted to, but I find it easier to reason about things in degrees than radians. We'll go ahead and see if this works. So we're modifying that path direction again by the direction angle, and then it's going to accelerate in that direction. So let's see if that creates a sinusoidal movement. So the snake has definitely got more snake-like movement here. So you can see here it's trying to reach that point and it's not quite hitting that point, so it just keeps going in a circle. And there it finally hit the point. So this is the problem with the sinusoidal movement, is that it deviates from the path to the point where it's hard for it to hit the targets that it needs to hit. Now that is producing some interesting movement. However, I don't think that that's ideal. We'll try the easy solution first. So I'm going to up it to 32 pixels as the desired distance. And we're going to see if that smooths things out a little bit. Yeah, that appears to be working pretty good, actually. Not in that case, though. So I'm going to do something else here. I'm going to add some functionality to my Pathfind component. So I'm going to do public bool can set target position. And I'm just going to return interval timer dot is stopped. And then I'm going to call this here if not can set target position. So again, I have an interval timer in here that just prevents resetting the path too much. But to alleviate the concerns of the snake never being able to finish its path, I'm just going to allow it to generate a new path on an interval. So instead of doing pathfind navigation agent 2D is navigation finished, I'm going to also do or pathfind component dot can set target position. Then I'm going to go ahead and do this and get rid of this set here. And so hopefully that's going to work. So the snake might get stuck at a point for a little bit, but it's going to end up having its path regenerated anyway. So now it's going to move a lot more sporadically. Now I probably do want to modify those timings because it is changing its path a little bit too much. But yeah, that's looking really good. All right, so let's get a bullet attack going. So what I think I wanted to do is follow the player during its bullet attack stage, and then also increase the sinusoidal movement, private, float, head, angle, degree, delta. Set that to 180 by default. So let's create a state bullet attack. So we got to add those 3 states. Okay, so we've got these bullet attack states in place, and now what I want to do is basically copy and paste a lot of what's in here. So I'm just going to copy all of this here. I might need to abstract this in some way, and I think that the easiest way to do that is going to be to create a new method called apply movement. We're going to need to set the Pathfind component target position, so we'll get rid of that for now. But I think that's fine because everything else is good. So this is all we need. This doesn't need to be here. So this is our minimal do movement here. So what I'm going to do is I'm going to call do movement in the middle here in the state normal, so do movement. So I'm going to acquire the target position before I call the movement, and then I'm going to do any other state stuff. And then I can do the same here as well. So in my state bullet attack, Pathfind component is navigation finished or can set target position. I'm going to say target position is equal to this.getPlayer.global position, or we're just going to fall back to the global position of the entity if the player doesn't exist, which should never happen, but defensive programming is generally a good idea. And then I can call do movement here. So I can now change that sinusoidal amplitude essentially when I enter this state and then switch it back when I leave this state. Node, private timer, bullet, interval, timer. And then in here, in this state bullet attack, I'm going to do if bullet interval timer dot is stopped. I'm going to grab my resource preloader, instantiate scene or null, bullet component, enemy bullet. Okay, and before I initialize the bullet, I need to add it to the scene tree. So this dot get base level dot enemy bullets or get parent dot add child bullet, and that should be it. And I also need to start the bullet interval timer again. Okay, so now I just need to add a little bit of a check in the state normal here. So else if bullet attack timer dot is stopped, state machine dot change state, state bullet attack. If I've done everything correctly, I should see that this is going to work now, and the snake should start sending bullets at the player every 0.15 seconds, and also aggressively chasing the player. Okay, yeah, that's looking scary, and it chases the player. So I actually probably want to increase the velocity as well. When I enter the state bullet attack, velocity component dot add speed % modifier. So we're going to make it go faster. And the string name is going to be name of state bullet attack, like so. And I'm going to give it a 50% speed multiplier. Those bullets are relatively slow, so I may actually end up changing those bullets there to be faster. Okay, yeah, that's very scary. I think the bullets are probably just a little bit too fast, so I'm going to knock it down to 275 instead. Oh yeah, that's real scary. Okay, I like how that feels. I like how that feels. I'm going to do bullet attack duration timer, and I'm going to do this anywhere from 4 to 6 seconds, and we'll do one shot on that. And I'm going to grab a reference to that. So private timer, bullet attack duration timer. So when we enter that state bullet attack duration timer dot call start random. If bullet attack duration timer dot is stopped, then we're going to switch back to state machine dot change state normal. All right, so now I need to fix the Y sorting issues. So the Y sorting issues being that the Y sort is happening based on this node's position, but I actually probably need to do Y sorting in a lot more sophisticated of a way. I need to turn on Y sorting enabled here. So in the ordering, Y sort enabled, and then I need to do that for all of these nodes as well. So ordering Y sort enabled, because the Y sort goes all the way down the tree. Basically, it goes on an unbroken chain of Y sort enabled nodes. Now this might end up messing with these components here, but I'm gonna see. So let's see if that even works. So what I should see is that I'm going to Y sort around the individual snake parts rather than the snake as a whole. Yeah, so you can see how I'm like, now I can go in between the snake parts. So all those individual parts are being sorted. The problem now is that it appears like my hit flash has broken. What I probably need to do is I need to wrap all of these in hit flash components. So I'm going to go ahead and do that. So all of these are hooked up to the same health component, so that should be fine. This ordering is still good. So now I need to change this code where I loop through the body segments. So when I go to my initialize body here, it's getting all the body segments. So I need to cast this as a hit flash group component like so. And then I'm going to do this .select x x.get first node of type sprite 2D to array. So just a little bit of extra work to be done there. So it's going to get the list of hit flash group components and then select the first sprite 2D node under each of those. All right, so the hit flash is back now, and the Y sorting is not quite correct. So let's go ahead and see if I can get that Y sorting enabled. Oh, I know why the Y sorting isn't working. I have to move these individual group components actually. So I actually don't want to select the sprite here. I actually probably want to select the hit flash group component here. So I think I should just be able to change the type here. There we go. So I've updated all the places where this is necessary. Now, hopefully the Y sorting works because now I'm changing the position of these hit flash group components instead of the sprites. So now the snake looks actually like he's, well, supposed to. Okay, now the other question mark that I have is whether or not I'm going to be able to add shadow components to these things. And I'm just going to say, well, I don't know if this is going to work, but I'm going to go ahead and just duplicate the shadow component and drop it into all of these. Now, of course, there's probably a better way to do that, but all that matters is that it works. So now that I've got shadow under the snake, hopefully, okay, yeah, so one problem we have here is that these shadows do not rotate with the snake. So I wonder if I could just enable rotation. So if I did an export here, export private bool enable rotation, then in my ready method, what I can do is I can say remote transform 2D dot update rotation is equal to enable rotation. I actually can't really tell if the shadows are a thing right now. I think the shadows need to be offset more. So I'm going to go back to my skeleton snake and turn up the distance. And then I'm going to go back. The rotation is actually looking fine. I just think the distance needs to be higher so I can actually see the shadows. It's not perfect. It's not like totally accurate to how a shadow should look, but you can see the shadow underneath the snake there when it's like that. And I think that looks fine. I think that's the snake boss. I may end up adding one more attack to him eventually, just so that there's more variety. And of course, I need to add sound effects and all of that good stuff, but that's basically the skeleton snake. He's not going to change that much between now and the release of Gunforged. So I hope that you found this deep dive part 2 interesting, where we finished the skeletal snake boss, which will be the 20th wave boss for this graveyard arena. Gunforged is releasing relatively soon, or if you're watching this video in the future, it may already be out. So check the link in the description below to wishlist Gunforged and purchase the game if it's available. And once again, I hope that you found this interesting and entertaining, and I will see you in the next video. Thanks for watching this video. If you'd like to support my work, you can purchase one of my courses, you can wishlist my upcoming game Gunforged on Steam, and you can sign up for my email list at firebelly.com. The links for all of those things are in the description below.